Alright, so the purpose of this video is to just work through some more problems with you. So here we go. A 3 kilogram pendulum is pulled sideways, so it is raised a vertical distance of 2.0 meters above the resting position. So whenever I was talking about potential energy and that ground level, here's a perfect example. This is the lowest that my pendulum is going to reach because the string won't let it get any lower. So this is going to be considered ground level. So when it says that it's 2 meters above the resting position, we would say that it has a height of 2 meters. Find the maximum speed the pendulum reaches after it is being released. So they are asking us for the velocity, but specifically, where is that velocity the greatest? So if we understand conceptually that it's going to be moving the fastest at the lowest point, then what they're really asking for is the velocity right here, okay? So remember, the main idea here is conservation of energy, specifically mechanical energy, where we have potential and kinetic energy. So we have two locations here. We have potential energy here, we have potential energy here, which means we must also account for kinetic energy here and kinetic energy here, okay? So at this location, we would say, at this location, we would say that we could calculate the potential energy of my pendulum by using mass times gravity times height. So 3 times 9.8, remember it's a positive here, times 2 is going to give me 58.8 joules of potential energy right here. Now, we hopefully understand that the object is initially at rest while it is being held in that position, and it won't have a speed until it is released. So we would say kinetic energy here is 0, okay? So then down here at the absolute lowest point, we are at ground level, so our potential energy now would be at a value of 0. I don't know how much kinetic energy my object has, but it must have some amount of kinetic energy in order to have that velocity. So here's where we need to understand that we could either say PE initial plus KE initial equals PE final plus KE final, where my initial kinetic energy is 0, my final potential energy is 0. So it's PE initial equals kinetic energy final, or what I would prefer is just to remember that the PE at the top is equal to the KE at the bottom. So I'm going to take my mass times gravity times height here and set that equal to my 1/2 mv squared. Now we've already done the work over here to figure out what that potential energy is. So I know you guys like to substitute your numbers in first. So 58.8 equals 1/2 of 3 times v squared. So half of 3 is 1.5, so divide by 1.5 on both sides. So then I get 39.2 is equal to v squared. And I'll square root that. So 6.2609, blah, blah, blah. So 6 gigs on this would be V equals 6.3 meters per second. Okay, next question. We have some conceptual questions here. I just want to make sure that we understand a couple of these things. At what point does the ball rise on the opposite incline? For this question, students, if they get it wrong, want to tell me that the ball is going to rise to point F over here. But here's the main idea that you are missing. this is the highest point, or this is the point that it starts from. So this height is the height that gives it its potential energy, which becomes its total energy. It cannot go any higher than point E on the other side, because if it were to go higher than point E, that means it would have a greater amount of potential energy than what it started with. And since energy cannot be created or destroyed, that won't work. So, since it starts off at location A, and we assume location E, A and E are the same height, E is the correct answer to that first question. Hopefully the rest of that is self-explanatory. All right, moving on to the next math question. Here it says that we have a box, and that box has a weight of 64 newtons. Okay, the ramp is 1.5 meters high. If 30 joules of energy is converted to feet, so this is going to be feet energy, how much kinetic energy will it have at the bottom? So KE here is what it's asking for. Okay? So this is once again going to be one of those questions where the PE at the top is going to be transferred into KE at the bottom. My kinetic energy here is implied to be 0. My potential energy here is understood to be 0. So we would calculate our potential energy by saying mass times gravity times height. Hopefully you guys have not forgotten that mass times gravity is how you calculate the weight of your object. So for this question, we are going to simply take my 64 times 1.5, and that gives me 96 joules. Now, when it says that we have 30 joules of energy converted to heat, remember I said heat energy is not going to be returned to our system, so it will not be recycled back into the potential kinetic energy or mechanical energy that we have available. So what we're going to do for this question is we are going to say along the way we are losing or removing 30 joules of energy. So the way that we calculate this final answer is to take the 96 joules that we had at the top, subtract the 30 joules of heat energy that it loses along the way, and what's left over is the kinetic energy at the bottom. Okay, next question. This question actually is one illustration where we're asking you at points along the way. This is a little bit more challenging because it really requires you to understand how the kinetic and potential energy transfers. So please pay close attention and follow along with me here, okay? All right, so the biggest mistake that students make initially is that they don't read carefully. At point A, so right here, we have the mass of the sphere, 68 kilograms. It has a velocity. G, the person, has a velocity of 6.3 meters per second. Okay. Number one, if you read this and you say, okay, at point A, KE equals 0 joules. And that's wrong. That is not how we answer that question. I said that we have a kinetic energy of 0 if we are at the absolute highest point and the object begins at rest. They just told us in the problem that the object has a velocity. So we are going to actually calculate this velocity, this kinetic energy here. So we have 1/2, or you can write it as 0.5 times 6.3. Oh, sorry, times 68 times 6.3, and only the 6.3 is being squared. And that gives you 1349.3 9.346 joules of kinetic energy. Okay, so now we need to calculate the potential energy at point A. So PE equals mass times gravity times height. So we're going to say 68 times 9.8. Again, it's a positive 9.8 because we are giving the magnitude of the potential energy that the object has, okay? So negative 9.8 is going to be this chapter. And then the height, we can see from the picture that at point A, we have a height of 12 meters. So 68 times 9.8 times 12 gives us 7,996.8. And then be careful over here, this does not say time. This says TME for total mechanical energy. So remember, mechanical energy is going to be comprised of kinetic and potential. So we're simply going to take these two numbers and add them together. And that gives us 9,346.26, okay? So this is how you go about calculating your values initially for our skier here at point A. All of the answers that go on the blank should be your official rounded numbers with sig figs and units. So based off of the velocity that we are given and the height that we are given, it's 2 sig figs. So this would be 1,300 joules. This would be 8,000 joules. Remember, I do not count off because it happens to round correctly to ending in a 0. We will still say that you rounded correctly to the second sig fig there. 9,300 joules. Okay? All right. Point B. It's asking us to do all the same things, but here's where you have to understand how the different types of energy transfer from one into another. And the main idea of conservation of anything is that the total amount is always accounted for, okay? So in a frictionless situation, we say that the total is conserved, meaning we have the same value for our total at all different locations. It's just changing how much of that total is in the kinetic form and how much of that total is in the potential form. So we can see at point B, we now have a height of 8 meters. So PE is the first thing that we're going to calculate. We're going to take our mass times gravity times our new height of 8 meters. Now, obviously, my skier lost height, so it's going to be a smaller amount of potential energy than what we started. Conceptually, I hope that's easy for everybody to understand there. And so now, my skier only has 5,331.2 joules of potential energy. So the total amount does not change, guys. The total amount does not change. So 9,346.26 is my total. 5,000 of that is in the form of potential. If you were thinking that you were going to calculate your kinetic energy over here by using this formula again, that's an awesome first thought. But remember, the purpose of identifying all of our givens is so that we can see how they fit into the formulas to help us pick our formula. And you can see that we currently do have a mass, but we do not have a velocity at point B, so we cannot use this formula to calculate our kinetic energy. So here's where understanding that conservation of energy is all we need to understand. If this is my total, I'm simply going to work backwards, and as some of you say, work backwards, and say, if this is how I find my total energy by adding kinetic and potential together to get my total, then in this case, instead of adding those two, I'm going to simply subtract 9,346.26 minus 5,331, and then whatever's left over is going to be in the form of kinetic energy. 4015.06. Okay, so once again, everything rounded for sig figs. If this is a quiz or a test question, that final answer needs to be rounded. So this is going to be 4,000 joules in the form of kinetic. So we have gained kinetic energy. We're farther down the hill. We're moving faster. That makes sense. 5,300 joules of potential. So we've lost potential energy because we've gone to a lower height, but our total amount of energy stays the same. Guys, that's the main idea behind how this works, okay? All right, so we have just a couple more things. There's one thing that you have not been asked to do yet, so I want to make sure I go over all of the different parts with you. So 9346.26, remember, was our total, and that's going to stay the same. So at point C, we are now on the ground, right here. This would be considered ground level. So when we go to calculate, we could definitely say that we have a height of 0. This is going to be 0. Anything times 0 is 0. So my potential energy right now is 0 joules. Done, easy. So then, if I have no potential energy and I started with a bunch, where did it all go? It was all transferred into the form of kinetic energy. So once again, if you were trying to solve this here, we don't know what that velocity is. Yes, my object is moving in this situation. It has kinetic energy, but since they didn't give me the value for my velocity, I can't solve that using the formula. You have to be able to understand the concepts and apply them to your situation when you are not given all of the values to just plug it into the formula. So in this case, all of my kinetic energy, all of my potential energy was transferred into the form of kinetic energy, and they once again have to add up to that total over there. So 9346.26 is how much kinetic energy we would have at the bottom of the hill. So, to write in our official final answers here. Okay, so now it's asking a new question. The new question is, what is the skier's velocity? So now they are asking me to solve for V. Hopefully by now we've got the point across. I've tried to be very thorough in my explanations. That velocity is going to come from my kinetic energy. So KE equals 1/2 mv squared is what we are going to use, and we are going to plug in all the numbers we know so that we can solve for that velocity. Okay. So for those of you who like to plug your numbers in first, here's how that would look. It would be 9346.26. Remember, use those unrounded numbers in all continued problems. 1/2 of 68 times v squared. So 1/2 of 68 is 34. So divide both sides by 34. And we get 274.89 equals v squared. And then the last thing we have to do is square root. Rounded for sig figs. Our velocity at the bottom is 17 meters per second. Okay? That's how you go about answering that question. The very last question at point D, what is the total mechanical energy? Total does not change, so it's just 9,300 joules. Okay? All right, one last thing for my students who are comfortable and confident in the algebra and they want to be able to just manipulate that formula so that they can plug that number in. You are going to be asked to solve for your velocity. And for some people, just figuring out how is that formula going to look when it's rewritten is so much easier than plugging in all those numbers and retyping numbers in your calculator. So if that's you and you want to know how would this look if I were to do my algebra first, we would need to multiply both sides by 2 in order to get rid of that 2 over 1. Then this would cancel, and then we would turn around and divide by m, so that would cancel. And then since that's v squared, the last thing that we would need to do is square root. So how would it look if we did our algebra first and manipulated the formula for my velocity? that's the formula you would plug in your numbers to in order to calculate your velocity. Okay? All right, I hope this was helpful so that you guys have a better understanding of how to read the questions. Again, do your list of givens. Make sure that you are looking for those easy, straightforward calculation questions first. But if the numbers are not there, do not try to force it. Stop and ask yourself, is there a set number I'm supposed to know? Is there a relationship I'm supposed to know? Can I go and calculate the missing value using another formula so that I can get back to my original question? Okay, hopefully by now those questions are habit for you whenever you feel a little stuck. So hope that was helpful. Have a great day.